Have you ever wondered what sound does the sun or the moon make? It's a fascinating question, isn't it? Let's embark on a sonic journey through the cosmos, starting with our very own star, the sun. Now, the sun doesn't generate sound waves as we know them because space lacks a medium for these waves to travel. However, the sun's turbulent surface does emit a range of electromagnetic radiation. Scientists can convert these into sound-like patterns. What we would hear is a complex symphony of low-frequency rumbles and higher-pitched oscillations, each representing different solar activities and phenomena. Next up, our moon. Like the sun, the moon doesn't have an atmosphere substantial enough to transmit sound waves, but it does resonate at certain frequencies due to impacts from meteoroids and the constant tidal forces from Earth. These vibrations, detected by seismometers placed on the moon's surface, can be converted into audible frequencies. The result? Low rumbles and vibrations, like the distant echoes of cosmic collisions. Moving on to Mars, its thin atmosphere isn't dense enough to transmit sound as we know it. But spacecraft on Mars have picked up vibrations caused by the Martian wind passing over their structures. These vibrations can be converted into sounds, giving us an eerie, high-pitched approximation of the Martian winds. Let's venture further to Jupiter, a gas giant with a turbulent atmosphere and powerful magnetic fields. Its strong radio emissions have been converted into sound waves. These sounds are often described as eerie and otherworldly, akin to a mix of whistles, pops, and crackles. Next, we encounter Saturn. Like Jupiter, Saturn's radio emissions have been converted into sounds. These originate from its magnetic field and interactions with its moons, creating unique sounds that resemble radiostatic and crackling noises. Uranus and Neptune, the ice giants of our solar system, lack solid surfaces, and their atmospheres are primarily composed of hydrogen, helium, and methane. Their radio emissions, like those of the gas giants, can be converted into sounds, producing abstract, space-like auditory experiences. Finally, at the edge of our solar system, we reach Pluto. Despite its distance from the sun and thin atmosphere, Pluto's interaction with the solar wind creates a faint and distant hum that might be converted into an extremely faint sound. Bear in mind, these descriptions are interpretations and conversions of non-audible phenomena into something our human ears can perceive. They're a creative way to represent the unique characteristics of each celestial body, but they don't reflect actual sound as we understand it on Earth. So, the next time you look up at the night sky, remember, each celestial body has its own unique voice in the cosmic choir.